We are starting on page 44 today. And our big idea is going to be looking at, now that we know what vertex form looks like, we're going to look at how to swap between the other forms that we have for a quadratic function. So we've seen standard form already. Standard form for a quadratic is the same idea as standard form for a polynomial, just our degree is going to be capped at 2. We've also seen factored form for a quadratic. It means that I'm only going to have 2 factors or 1 factor squared, but that's the same as a polynomial. And when we looked at these different forms for polynomials, we talked about how to swap back and forth between those forms. Now we've got this other form that's specific to quadratic functions called vertex form. So we're going to look at how to swap between vertex form and standard form, or vertex form and factored form. So for today, we're going to look at starting with vertex form and changing to standard or factored form. Your notes for tonight are going to go over, if I've got standard form, how I can get vertex form. And again, this is all stuff that you guys saw in Algebra 1, so it should be familiar, but we're going to go through it again because it's been a little while and make sure we're all on the same page. So starting off on the top of page 44, it says we have factored form for a polynomial function. How could I change it to standard form? So if I've got something like this, factored form, how can I get standard form out of that? Distribute. Yeah, I'm going to multiply these things together. So if I distribute, I would have x squared plus 1x minus 7x minus 7. And then don't forget to combine like terms. And my function in standard form is x squared minus 6x minus 7. Remember, standard form, I've combined all like terms. I've got the term with the greatest exponent first, and it goes in descending order down to my constant term. Okay, so if I have a function in standard form, how do I change it to factored form? If I want to get factored form, what do I have to do? I have to factor it somehow, right? Maybe AC method, maybe difference of squares, maybe grouping, but I'm going to use some sort of factoring method. So I have to factor. Okay, so to get it to standard form, we distribute. To get it to factored form, we factor. So if this is my function here, and I want it in factored form, I need to factor it. So since I have a lead coefficient of 1, I'm just going to do that sort of abbreviated AC method that I called it kind of guess and check in our notes. So I need factors of -8 that would add to -2. That would be, whoops, sorry, -4 and 2. So my factored form would be x minus 4 times x plus 2. So there's my factored form. So this is what we've done already. What we're going to look at today is now if I start with vertex form, how do I get standard form? Or if I start with vertex form, how do I get factored form? Okay, that's going to be our focus for today. So the first thing that we're going to look at is how do I change a quadratic function in vertex form to standard form? So vertex to standard. Okay. Same idea as to get it from factored to standard. We're going to distribute, combine like terms, put it in order. The only thing I need to remember that's different is that if I have an exponent here, which we will because it's vertex form, that exponent means I need to write that factor twice and distribute. So I have x minus 1 times x minus 1. And I want to distribute and then combine all my like terms at the end. So this would be x squared minus 1x minus 1x plus 1, and then don't forget your plus 3 at the end, and then combine your like terms. So I've got x squared minus 2x plus 4. Okay, very similar to what we just did. Here I've got a lead coefficient. So this means I've got 3 times x plus 2 times x plus 2 minus 5. So I've got 3 things to multiply here. It doesn't matter the order that you choose to multiply those things. The important part is that you multiply only two things at a time. What I see pretty frequently on problems like this is that someone will distribute the 3 into here and into here. That's too much, okay? So remember, if I were gonna multiply 2 times 3 times 4, I would multiply two things together and then multiply that by the third thing. What we would not do is 2 times 3 and then 2 times 4 and then multiply those answers together, right? This would be wrong. That's too many 2's. So don't do that here either. So I'm going to distribute in the 3 to start. If you want to do this first, you can, and distribute the 3 after. Doesn't matter. Just pick 2, multiply them, then multiply by the other thing. So this is 3x plus 6. And then I've got to multiply this by the x plus 2. So that's 3x squared plus 6x plus 6x plus 12. Don't forget to bring down that minus 5. And then combine your like terms. So our standard form here would be 3x squared plus 12x plus 7. Questions for me? Okay. So to go from vertex to standard, we distribute. Just like if I'm going to go from factor to standard. Same idea, combine your like terms, make sure you put all your terms in order. We can, in some cases, also take a function from vertex form directly to factored form. Not always, but in some cases, we'll have a nice setup where we can actually treat our vertex form sort of like a difference of squares problem. So if you remember, those difference of squares problems were when I had, let's say something like 4x squared minus 9. And the idea was that we looked at what did I square to get the first term? What did I square to get the second term? So to get 4, we squared 2. To get x squared, we squared x. To get 9, we squared 3. And we said, hey, this is a difference, subtraction, of two things that are perfect squares. So we can factor that like this. We had that sort of special pattern we used. So it was the first thing at the front of each factor, the second thing that I squared at the back of each factor. One factor got a plus, one factor got a minus. That was our difference of squares sort of shortcut for factoring there. We can use this same shortcut for some of our vertex problems, okay? So what I want you to notice here is that this is already written as something squared. So our 4x squared here we rewrote as 2x squared. This is already something squared. And then I got subtraction. And then 16 we can write as something squared. What would I square to get 16? 4, yeah. So I've got x minus 3 being squared and 4 being squared. So I can write this as a difference of squares. First thing at the front of each factor. Second thing at the back of each factor. One gets a plus sign, one gets a minus sign. And then I've got one more step here. I'm just going to tidy up these factors. So this would be x negative 3 plus 4 plus 1. And then x minus 7. Now, I understand that this is kind of a weird way to approach these problems. So we're going to take a look at a couple more examples of this. Let's take a look at our next example on the bottom of page 44. So notice this time I've got a lead coefficient that's not 1. I've got a number in front of that sort of squared factor. So what I'm going to do is actually factor this out of both terms. Now, when I factor it out of the first term, it's just not going to be in front of the squared part. And then when I factor it out of here, 8 divided by 2 gives me 4. Now I've got something that's a perfect square. So we can use that difference of squares method here again. This first guy's already written as something squared. If I wanted to write 4 as something squared, it would be 2 that I would square to get 4. So then this becomes my GCF times x minus 1 plus 2, x minus 1 minus 2. If I tidy up my factors here, I get 2 times, this would be x plus 1, and then x minus 3. Questions for me so far? Okay. We're going to skip page 45 for now and turn to page 46. And we're going to look at a few more practice problems here for the same type of material. So at the top of page 46, you have 3 problems to change your function from vertex form to standard form. And then the next section is to change from vertex form to factor counts. Those are the 2 types of problems that we looked at. So that's where we're going to focus on page 46. Okay. So if I take a look at number 1, remember I want to rewrite this squared thing as 2 factors so I can distribute. I don't care the order in which you distribute, just make sure you're not distributing or multiplying more than 2 things at a time. So I'm going to distribute this guy. That would be negative 2x plus 2. And then I need to multiply that by the other x minus 1. So that would be negative 2x squared plus 2x plus 2x minus 2. And then don't forget our plus 3 at the end. And then I'm going to combine like terms. So I've got negative 2x squared plus 4x plus 1. Let's take a look at number 4. So we've got vertex, we're going to change it to factored form. So we're going to use our difference of square structure here. My first term is already written as something squared. What would I square to get 16? 4. So this would be x minus 3 plus 4 times x minus 3 minus 4. And then just combine your like terms inside your factors. So we would get x plus 1 times x minus 7. I would like you now to try the remaining 2 problems in each of these sections. So number 2, number 3, number 5, and number 6. Try those remaining 2 problems in each section. For number 2, remember that you're distributing. So this squared factor you need to write twice so you can distribute. And then don't forget to combine your like terms. For number 3, I'm actually going to do my distribution first and then multiply through by a half. You can, as I did in the other problems, multiply in the half first if you'd like. I'm going to choose to multiply x minus 5 and x minus 5 first, just because I don't want to have to deal with a fraction for another round of distribution. So I'm going to put the fraction off till the end. So this would be x squared minus 5x minus 5x plus 25. And then I'm going to clean this up here. That gives me x squared minus 10x plus 25. And now I'll distribute through that 1/2. So I would get 1/2 x squared. And then half of 10 would be 5, so minus 5x. And then half of 25 would be 12.5. Or if you left it as 25 over 2, that's fine as well. For number 5, I need to start by pulling out that lead coefficient. So I would have x plus 1 squared minus 27 divided by 3 would be 9. Now I've got something squared, and 9 is 3 squared. So I can do that difference of squares here. So we would have 3, the same 3, times x plus 1 plus 3 times x plus 1 minus 3. And then again, don't forget to clean up your factors. So we would get 3 times x plus 4 times x minus 2. And then number 6 is just like number 4. I have something squared for my first term. What would I square to get 4 here? 2. So this would be x plus 3 plus 2 and x plus 3 minus 2. And then clean up your factors. You would get x plus 5 and x plus 1. Questions for me for today? Okay, so we're going to continue to see this and continue to work on this for the rest of this week. It's going to come back next week. These are this distributing and then using our difference of squares factoring. Okay, our skills that we're going to continue to use. For tonight's homework, you have a video over your next set of notes on Delta Math. It's going to be over the stuff that starts on page 47. I believe it's pages 47 and 48 you're going to see in your notes video. To the top of page 48, I believe. So notes for tonight. And then we're going to do some more practice in class tomorrow over the stuff we've just seen, over some older stuff to bring back to review, and over the stuff that you're going to see in your notes video for tonight. Okay, so notes video on Delta Math for tonight.